Well, to be honest, I never thought I'd become a president of a university. So in a sense, there is a chance for you to impact a country, to reshape the culture. When people see something amazing, they literally get scared. I think there is a need to enhance the education of AI. Many of the assumptions about the AI regulation discussion and even panic is also based on unclear understanding about the power of AI. We don't have such a literacy, and that's where, from the educational standpoint, I would like to see universities start thinking about that.
Welcome back to the Deep View Conversations. Today for our second episode, I traveled all the way from New Jersey to the United Arab Emirates, specifically Abu Dhabi, which is the home of the Mohamed bin Zayed University of Artificial Intelligence. This is the world's first and only university that is focused exclusively on AI research. And right now, I'm speaking with Dr. Eric Xing, who is the president of MBZUAI. Eric, thanks so much for giving us the time.
Well, thank you for traveling all the way here. I appreciate your diligence, and I love to chat over anything that you are interested in.
So I want to start with you, right? And as we've kind of talked about before the cameras started rolling, right? Your background is in research, and you've been a professor, and you still kind of wear that research hat. How do you go from a professor of computer science to the president of MBZUAI? What's that journey like?
Well, to be honest, I never thought I'd become a president of a university, at any time. I'm still right now affiliated with Carnegie Mellon. I've been working as a professor in Carnegie Mellon since 2004. I advise students, I teach classes, I write grant proposals, and write papers. In fact, I'm still doing all this right now, except for classroom teaching. So research is very, very strong, very, very important for me. That's why, I haven't thought about becoming a university administrator. During my career, when I become senior, I did receive numerous invitations and requests to be department chairs, deans, even in one case, another president, in a different institutions in the United States or in UK and other places in the world, and I didn't leave Carnegie Mellon. So when I got an invitation for interviewing here, I thought it's maybe a learning experience for me to see the place and also to maybe offer my insights or maybe experiences or opinions to the leadership in here. During the interview, my interaction with the host here is mainly based on my identity as a researcher, as a developer, and as a scientist. So I give them basically the viewpoint, from that angle, how a university should be built, should be operated, and what's the best function and reputation for university. And I also know that I'm not the only one they interviewed. They interviewed quite a few people. All of them are much more senior and recognized than me. So I wasn't taking it too seriously to be a real job interview. It's really a exchange, intellectual exchange. So I went back home, but then after some time, to my surprise, they made an offer to me. I wasn't ready at all, to take this offer because at that time I'm still very busy working with my students and working on a few exciting projects. That was at the beginning of the COVID. In fact, the trip to UAE for the interview was the last trip I made before travel shuts down, in the States and around the world. As we entered the COVID season, things changed a lot, even back home in the States. You are locking down at home. You don't really got to see your students so often. You teach through a camera, which all were very new to all of us. And you started getting yourself isolated from the rest of the world, which is good and bad. I didn't like that experience. I feel research is it is important, for science to be done collaboratively with colleagues, with students. So I missed that part. But on the other hand, it gave me the time to think and to really ask myself again, where I'm heading, right? So with this offer, which is definitely non-trivial, it is supposed to be bringing me to a place that I've never had previous interaction and experience with, and also it's a job I've not done before, right? So I consulted some of my colleagues, mentors, and friends. Professor Sir Michael Bradley, the former acting president of the university, he made me a very, very interesting case. He said, look, this is more than just a university administrator. It is about creating something from scratch, with a clean slate, and also it is in a region where no such university ever existed, and the country and the region needs such an institution to really be the beacon, of a new culture. In a sense, I have the opportunity to influence and to shape a new type of culture, to really help, a whole people, a whole country, to seek new directions, or create new results, and also to redefine, some of the decision process and the operation and even culture, in the region. So in a sense, there is a chance for you to impact a country, to reshape the culture. So that's quite exciting to me. I'm always very adventurous in trying new things, and this is definitely very new. Then I asked another friend and mentor, Professor Michael Jordan, who has been, my advisor, back in UC Berkeley when I was doing my PhD. But then we kept the friendship, all the way. And he also strongly suggested to me, to consider this opportunity more seriously. He said, Hui, you are a professor and a researcher with a good track record of being productive and being creative, on the scientific part. But what could be the next big stage? And that's what he asked, right? He understands that I want to continue to do science, but bigger science also requires bigger resources, and also from a pure career development standpoint, getting such an offer in a relatively young age really actually means that you have the opportunity to experiment and also to try different new ideas. In a sense, you have a chance to fail and do it again, do it differently, and so forth. So he said this is a once-in-a-life opportunity because not every country are trying to build a university of this, and also not any time such thing can happen. This is maybe just a once-in-a-life opportunities. So these are the two strongest positive input I can remember. There are other inputs as well that are as positive. But of course, I also received a lot of warnings and negative feedbacks. It is very risky. It could ruin my career and reputation if I do it, if I screw the job, or I may run into a very different culture that I just cannot understand and work with. All these pragmatic issues and other things. Yeah. So I took a step back and I took advantage of being in the height of the COVID with very few people to talk to if I don't actively seek out and did some in-depth thinking. And in the end, I think I will be living in my house probably for the next God knows how many months and years. I wouldn't be able to achieve too many exciting things anyway. And this particular opportunity is indeed once in a life, right? And from a technical standpoint, I start to see, AI is a rising sun on the horizon. The established university infrastructure is already having difficulties in coping with the new needs, the new culture, and the new, evaluation and merit metrics, in this new discipline. But it is very hard to change a established organization. So even from a professional growth and the development point of view, it is opportunity to take your fate into your own hand, and also maybe create an environment that can help many of our colleagues, students, and of course the country and the people in this region to a brand new setup of such institution, right? So I see that as I start to appreciate that's becoming a huge opportunity that I can really make a difference, because I am an active researcher, and it is not so common, for a active researcher and teacher to jump into a university professor role. Usually, the typical president you see are already somewhat removed from the daily scientific life and teaching life. Therefore, it can be difficult for them to appreciate, from a close distance, the difficulties, the needs, and all that, in programming and in organizing the university, right? So all this converged to, a decision that, I'm going to give it a try. And then, it took me a year to make that decision. I actually felt really appreciative that the university was able to wait for me for that year. In fact, also the Board of Trustees, they had the patience and also the trust on me, to onboard myself. I remember, it took me some effort, took everybody a lot of effort, in fact, to even make the trip to here, because all the flights, were unpredictable, and even getting a COVID test certificate is also unpredictable. But you need that to board a plane, right? And which is a 24-hour fresh kind of certificate. There are a lot of logistic challenges. So eventually I made to Abu Dhabi one day before the first class of the student open. I remember I get myself prepared in a temporary residence that I basically borrowed a room, from a very kind host. And I delivered the opening speech, of that class, again from a Zoom meeting, with actually, very simple, not as fancy as today, the recording devices, which is coming from my computer camera. So that's basically how the whole thing started. At that time, the university was really, really very young and weak. It has barely, I think, less than a dozen faculty, and only one class of students, which was very good, but at least I didn't have any control or knowledge about that, because I was not admitted, under my kind of a direction. So we literally walk into the unknown, and that basically sets off into the whole stage.
If you run a startup, you're going to want to pay attention to this. Startups, especially AI startups, need good cloud providers. Lucky for you, Google Cloud exists, and they offer an experience, the Google for Startups Cloud program, that's tailored specifically to you. The program offers eligible startups up to $200,000 in Google Cloud credits for up to 2 years. For AI startups, that number is $350,000. Plus, you get the mentorship and experience of Google Cloud's top-notch team. What are you waiting for? Start building today with Google Cloud at cloud.google.com/startup. That's cloudgoogle.com/startup. Yeah, it's quite a journey. Now, about AI specifically, right? Mm-hmm. And I know you've had an interesting journey with that. You started studying molecular biology, and you kind of jumped into machine learning. You've said of AI that it could usher in an age of empowerment. The printing press ushered in the age of enlightenment, and you've kind of equated the two as somewhat similar and how society changing AI could be. What does that age of empowerment look like? And from where we're sitting now, what's the gap to get there, and how are you trying to bridge that gap?
I'm glad that you asked this question because many people would ask how to achieve artificial superintelligence and so on, and then what is that, right? So, yeah, I think I like to see any innovation and breakthrough from a utility standpoint, what function it delivers, and how such functionality change people's life, change society, and maybe even change civilization, right? So it is in that context I call AI to be equivalent to the breakthrough leading to the age of enlightenment, which is the printing press. There are many, many other inventions. The invention of the steam engine, for example, the discovery of electricity. All these are huge, right? But I think AI and also printing press, or the invention of letters and writing are at a different level, compared to all these technical innovations. Because if you look at, if you put AI and the printing press and maybe the invention of paper and writing next to each other, they have something in common. It is actually the backbone of human civilization in their experience with information, right? It's about how we process and store and use information, in a massively different scope of magnitude. When you have the technology of writing, use language and letters and characters and papers, then the information can be recorded rather than through verbal communications. I remember, is that Plato, who I think Plato is a student of Socrates, right? Socrates didn't actually believe that knowledge one should write any book. He believed in in-person experience of teaching, but it is Plato who convinced him, or maybe who took on the job of taking down all Socrates' teaching and ideas into writing. And now we appreciate how important that is, because that knowledge can pass down to generations as it is. So in a sense, it is a embodiment of the antiquity time, information technology. But at that time, you need to copy the book, and the people who own the book, need to be literate and also need to have that kind of status, have the opportunity to access to that. So knowledge belongs to a very few people. Printing press is a major advancement, unlocking the knowledge from a few people to everyone, because it allows every people to have their own copy of the book, which began from the Bible, and they can form their own interpretations and understanding. And then after that, people start to think, basically, based on that from those knowledges. And then they write more books, right? So we have really even the university evolving from a theoretical school to study every topics. Now, why AI is directly related to that train of evolution. If you look at large language model, for example, it is trained not on one book. It is not trained on one sector of knowledge. It is literally trained on everything ever written into language, through civilization, and also in any media, right? In a sense, you can imagine it is about turning all the libraries in the world into one device, and then make it available next to your fingertip. You can basically now easily get knowledge and learn from it, using this interface, and which makes again, the knowledge broadcast and storage and accessibility, to a different level. Then AI also not only retrieves knowledge for you, it actually started to be able to use the knowledge to solve problems. As we can see, they can at least answer many of your questions. And they can also start producing, for example, code and softwares, right? And nowadays, people are trying to develop a lot of applications, in different sectors based on that, because knowledge, can be actionated to solve problems. And in that sense, I call it a empowerment after enlightenment. It is not about just giving you the space to think. It is now giving you the tools to make you a more powerful enabler or actor, in whatever occupation that you do. And then, in a sense, leave you out space to do maybe more challenging, intellectually challenging things. And so that empowerment comes together with even a next level of enlightenment, where everybody can do very often time a very advanced level of work without necessarily spending 20 years of training in school. And then people should now start rethinking what I'm going to learn now in the next 5 years, and what kind of problems I should tackle. So we can refocus on problems and maybe needs, rather than just focusing on repeating, executing a known solution in different, application context.
The difference to me between the large language models that we're kind of dealing with today, right, and something like the printing press, is, I think of all these technological innovations as levels of automation, right? The printing press, as you said, instead of having to handwrite books and pass them out, right, we have copies of stuff. It created more accessibility. The jump to language models and the kind of generative AI we're seeing now, to me, what you're starting to do is you're starting to take the human out of the loop to a degree. Do you see some sort of risk in that environment where, maybe for some people it might unlock them to explore greater problems? Is there a concern that for other people it just acts as a crutch for human intelligence, human creativity, because you have everything accessible, you don't have to think as hard?
I don't deny that there is a risk. In fact, any new technology, comes together with both opportunities and risk. Just like, even we talk about something that we are very familiar with, medicine, for example, there are always a side effect that we need to control. That's why FDA is formed. Genetic engineering, we use them now to dramatically raise the productivity of crops. And we can engineer, into the crops, or the cattle or the livestock, some nutritional deficiencies and so forth. But, you can also use that technology to create very harmful, viruses, or other form of toxicities, right? So it's really about, how to mitigate and how to regulate those risks. I think AI is not an exception, but on the other hand, also not a unique threat that we didn't deal with before. There is in the past, people figured out that there is a clear distinction between the science, the technology, and the product, right? And where you set the brick and where you regulate, is well understood that you probably should focus more on regulating the users, on regulating the distributions, but on the intellectual part, which is the science, and maybe even the technology, which is the production part, you use a different type of management. Typically, for the science part, you don't even manage, or you manage very little, because the creativity, once you shut it down, the cost is too big to bear, right? In fact, many of the assumptions about the current rush, into AI regulation discussion and even panic is also based on a unclear understanding about really the power of AI and how powerful and how potentially dangerous it can be, right? it is not well understood, especially by the general public. Sometimes, even from a tactical standpoint, even if there is a risk, how material that risk is, and it actually had a big impact on the risk and the benefit calculations. So I want to say a few words about really where we are, in AI in terms of its danger and its risk. Yeah, AI is more than automation for sure, because AI can automatically learn skills, from training materials. So it is one step, beyond just a programmed automation. It does have the ability to acquire knowledge and to become more and more powerful, once you plug them into, some data sources and also run an algorithm. But on the other hand, AI also has a lot of limitations. It is not a living creature that has self-identity, self-drive, agency, free will, and so forth. In fact, it is unclear to me, at least, where all those will come from, based on the current architecture and our current mathematics of doing things, right? I think down the road, new architectures beyond transformers, new form of data beyond text and image will be fed into the next generation systems to create more functions. But these functions actually are still quite a few steps away from the type of higher level intelligence or human-like intelligence I just mentioned, like agency, like identity, like a will, and so forth. For example, how to even do more complex reasoning, multiple steps reasoning. You want to plan a shopping trip, a travel, and purchase a flight ticket. Plan on hotels. That requires multiple steps of reasoning. I don't think right now the current version of GPTs is able to do well on that job. Now, talking maybe a slightly more challenging task, how to run a store, how to run a company, how to win a campaign, a battle. These are reasonings which are typically hundreds of steps, conditioning on real-world environments, and also conditioning on embodied experiences from sensories and from anything. And these are very difficult. In fact, you can probably already find out that you cannot ask, for example, a GPT or AI assistant to teach you how to swim, to teach you how to play the music. Because why even different music mentors, why we have master classes? Those musicians, when they teach you, it's not about reading from a book and say, hey, you apply 2 grams of force onto a key and hold for this many milliseconds and to produce a sound. It's a very different experience, of music teaching. And I don't think right now, our AI system is even designed to do that. And certainly they cannot do that. So I think the current AI system is still, on the steep learning curve to gain more capability. Whether it has the risk that people are now, fear about, I think it's premature to say that. Now, people say disinformation, deep fake, and all that. These are risks not coming from AI technology. It is coming from the users of the AI technology. Okay, it's just like a gun. You definitely can cause a lot of harm by using the gun. But is that the mistake of the gun? People are still making better guns these days, right? And for whatever specific purposes. But how to regulate its usage is the key. So I would like to remind, policymakers and the general public to really be a little bit more concise and careful about where the focus is in such AI risk and AI regulation conversations.
The AI regulation conversation is very broad, right? There are some instances that are trying to be very focused, such as with deep fakes and job loss related to deepfakes in the creative industries. There are others that are trying to mitigate and prepare for these hypothetical risks that we don't really know if they'll happen at all. And if they do, we have no idea when, right?
Yeah. And I want to add one more thing. In fact, even if you want to regulate and counter that, you actually need AI to do it. Because the deepfake images and the videos, the misinformations, it's just too much for people or for a manual devices or approach to discover and to contain all of them. Unless you shut down a computer, every computer in the world, they will be generated. And then you actually need a better AI to counter that.
As you just said, right, the problem with this technology and regulating this technology is it requires a global effort. If one country regulates really hard, that's not going to stop China or other countries from not regulating it at all. And I think there's some concern about that.
Yeah.
The way you kind of frame the regulation question was to focus on differentiating development from deployment.
Exactly. Yeah. That's why I think, for example, you said about adversarial scenarios that certain countries like China will be doing what they need to do anyway, and you cannot stop them, right? I think the best, thing that one can do is to advance your own technology. In fact, to make AI even better. Even we are under a material risk, we have the means, to take care of that, to counter that.
And do you think it would be an achievable thing? There has been talk about the idea of international governance of AI that kind of supersedes any individual efforts. In the US, it's even more fragmented because you have states doing things and then the federal government is trying to figure stuff out. The EU is moving and that'll impact where companies deploy. But the idea of, getting every developer around the world, from universities to corporations, to agree to a set of guidelines that maybe safeguard deployment. Do you think that's feasible? And should it be feasible?
I'm actually optimistic. It's absolutely achievable. But on the other hand, I have to also point out that if you look at the age of enlightenment, after the printing press, it took roughly 100 years before, all the warring states to eventually, align on some common principles, and also to learn how to live with this technology. In West Europe, different religious sectors, fought to death, just because, a different interpretation, of a Bible principle, after all the people learn about it and have their own interpretations. But eventually, they learn how to settle things. And also they learn how to live with a new society that all can read and have many books and so forth. Right? And I can also name some counterexamples where printing press was actually banned. And after some 100 years, those regions become much, much less developed than the West European countries. Why I mention this? Because I want to emphasize the importance of experimenting and also the time. We are just barely 5 years, or maybe even 3 years into the age of large language models, right? So the AI era has just started, and it is also evolving very fast. We actually don't even see, where it will platoon and how a steady state would look like. And that's why I think at this point, rush into a premature set of very stiff laws or regulations isn't going to be very helpful, because it may cause missed opportunities, and also, maybe an awkward misfit, of all these, policies, with respect to the real world, how they evolve, right? So I would say that first, from a scientific standpoint, we need to collect enough data points and make careful observations and analysis about, the opportunity and the risk, and also the trajectory of the technological development, thinking ahead of the curve, and be able to predict where that technology is evolving, where I should put kind of a gate, or a checkpoint down the road, rather than kind of a passively, chase, a running kind of objects and interfere with some of the, very organic and natural and creative and productive kind of activities of scientific advancements.
The trick is just trying to figure out where it's going to go so you can get ahead of it.
Yeah, and it will take some time. But of course, I'm optimistic that it wouldn't take 100 years. It wouldn't be as terrible and as costly as the religious wars, we experienced, after during the Enlightenment age.
Now, you talked a minute ago about we don't want to miss the opportunity, right? And we've talked about how impactful this technology can be. I've been obsessed with this idea of trying to narrow down on what the true promise of AI is, because like you said, I think a lot of people misunderstand what the technology is itself. Part of that is the fault of the kind of hype of corporations that we've been seeing, and social media is not helping. Part of that is the fact that for a lot of subject areas within AI, we don't have unified definitions, right? Or people say one thing when they're talking about something else. But trying to narrow in on the idea of what is the promise of this technology and how it can help people, because I think in a lot of cases, people are afraid. People are afraid about losing their jobs. People are afraid about existential risk scenarios, which get kind of thrust upon them from some of the companies developing this technology. And it's set up as something that seems to have so many, it's set up as something that's dual use, but it seems to have so many negative risks that I think for a lot of people, there is a question of why develop this at all if the risks can range across this realm of severity. So to you, what are we trying to achieve? What will AI help us unlock?
Yeah, that has a close connection to really the level of functionality that the AI, will be achieving step by step. And at every functionality, you can accordingly kind of define the cost and also the opportunity. For example, Henry Ford used to say that every American needs to own a car. And I think it's very bad news, to the train drivers and maybe to the carriage drivers, right? But look, if every American needs to own a car, the number of workers to produce those cars will be humongous. In fact, it ends up like creating the job. Now imagine that in our household, we want to have a robotic maid to just take care of all the the household businesses. Wouldn't that be an amazing product that everybody wouldn't object to? I don't think right now people object washing machines, right, and so on, right? So that's a huge market. And the key technology to get there is AI. You need to basically have a robot that is able to plan, able to act, be able to understand, communicate with you, and also, get things done, right? So we are actually, honestly, many years away even from achieving that. But in achieving that, I would imagine that everybody want to be in that business and join the production line and make a lot of money out of it. Yeah, you will be losing, of course, the cleaning ladies may be losing their job, but they will get a better job elsewhere because you will be joining the production line in different steps of producing that amazing machine, right? And also, we talk about AI being replacing some even white-collar fancy jobs like a accountant, like a legal worker, because we see ChatGPT are passing the bar examinations, passing the medical examinations. Wouldn't it be nice that it freed up these very smart people to think about new practices in those domains, right? So I think Sam Altman, from his business standpoint, defined a few tiers of AI, right? I don't want to comment on whether those steps are too ambitious, or or maybe less realistic. But I think the way of thinking is very clear. It is aiming for higher and higher functionality. And what I can say from a technological standpoint, it also will be dependent on multiple generations of data, architecture, and algorithmic evolutions. We're not there. In fact, we don't have the tool right now to achieve even his second and third goals. And within these second, third, and fifth goals, in fact, I can define multiple concrete reasoning and also acting tasks that requires a lot of innovations. So at this university, in fact, we were involved in some of this work, such as developing the post-LLM models, including the word models that can even do a trivial thing of simulating the word. If you cannot simulate the word, how can you even teach a guy to pour a glass of water? That's actually not written in the book. Okay. There are many other things that require you to be able to simulate real-world experiences and also generating the next word based on your action on the real world, and so on and so forth. And only in that way, you can start to do thought experiments. You can do a new form of reasoning by simulation, which could overcome some of the limitations of the current language models. Then once you have the word model, you can go one step further into an agent model where he has the word model as the brain, but also he needs to have other mental devices such as perception, and goal, and the belief, and all these kind of things. Each of them requires another model architectures. So I can go on and speak maybe for an hour about the technical steps that is required, right? Even to achieve what we probably can see as a very normal and tedious level of intelligence. Then I want to also say a few words about the other opportunities that is beyond our daily life, which is the AI for science. Doing scientific research is always a function of a technology environment. Science requires more than brain, it requires the tool, right? Microscope, telescope actually play the bigger role, in advancing biology and physics. AI is actually one such tool. Right now we have, for example, in the space of medicine and biology, there's a huge amount of genomic data, proteomic data, and all sorts of omic data that is not meant even for people to analyze because they are too big and too complex. Before the modern AI of large language models and foundation models, we can do very little in understanding and utilizing the data. And now there is a new movement, in fact, in computational biology of building foundation models to distill in an unprecedented way, new form of knowledges and also predictability and simulational capability of biological systems. Imagine that. What if you can now use an AI model to make proposals in a very, very short amount of time of hundreds, if not thousands, of drug design that can be applied to cure a particular diseases. And then you don't have to even apply the drug to a real kind of biological system like a cell or a model organism. You can actually also do the same in a word model of the biology, which simulates, all biological phenomena and the responses up to perturbation. You can pretty much do this a whole loop of innovation and design and the experimentation, on a computer. And that actually is now becoming a very, very exciting goal for many of my colleagues, including students and professors in this university. Likewise, you can draw the same experiences or expand the same experience in physics, in agriculture, in many other sciences. So I think AI will become, again, the modern day new microscope, which helps you how to understand the complex data, just like the classical microscope did, which is also about helping you to understand the information that you cannot see, too small or too far away from you.
So you were talking about limitations of the current architecture, and something else you mentioned that I want to tie into this as well is that you refer to AI as our new age microscope, right? In the ways it'll advance science. and not as a species, right? And I think a lot of the source of where the fear is coming from and where the hype is coming from, and I think those two are very interrelated, is this language around AI, and some researchers have taken issue with the term AI at all because of this, as the creation of a new species, as a species to supplant the human species, as the kind of next thing, and like we are creating this being thing, replicable, whatever that is, right? And it's vague if you try to pin it down, but the way you're talking about it, with the limitations and the focus on it as a specific tool, is very different. And so, one, I want to start with what those limitations are. We talk about hallucination, we talk about biases, and these kinds of inherent issues to the architecture. What's also the importance of the language and how these things are discussed?
Whether AI is a species and so on, these kind of discussions rarely happen among scientists and engineers. Right? I call them the consequence of people living in different dimensions. Imagine that there is a tribe, somewhere in the Amazon jungle that have never seen, an aircraft, or maybe a car, and then all of a sudden they see, a person landing, from an aircraft. It is not going to be surprising that they take that as a new species. In fact, if we look at the ancient mosaics and pictures and sculptures, in Egypt and in other ancient civilizations, you actually see a lot of such depictions, of a godlike figure, or magical species, which I don't know, may actually represent a machinery. That's very possible, right? So there is a key, distinction between technical and a scientific discussion from maybe romantic and humanity discussions. For example, this very word of intelligence. Intelligence is not a very scientific design. I regret actually our discipline is called artificial intelligence, because the other fields are called physics and biology. It's a noun. Intelligence is a noun, but it is derived from an adjunct. You are intelligent and so on. It's a very subjective thing. For example, imagine that I have in my hand, a calculator, and but I didn't tell you. In fact, especially for people who didn't know the existence of calculator, he will be amazed, how fast and how well I can do not just the trivial calculations, but also square roots and the integrations and everything. I can be called very intelligent, but it is a calculator. Once you are in the same dimension, you see how it is made and how it is supposed to function, you would be less impressed and nervous. For example, large language model, right? We build it. In fact, we are building it here as well in MBZUAI. We are among the few universities, if not the only one in the world, who actually pre-train large language model of our own. It is a model, it is a language model doing one thing, which is the next word prediction, right? So in that function, many of the utilities somehow can be encapsulated and dispatched. For example, answering all your questions, in a certain scope. Because next word prediction is like a linguistic simulator of simulating, how a person would react to a prompt or a question through language. It is literally, a definable and a measurable function, but human being may, respond in a certain way. In fact, even between different human beings, we do different. Some people recite some text. They need to have a script to read from it. Some other people improvises. Some people are half-half, right? So the approach of achieving that to a receiver is actually less relevant. They draw on the experiences. Now you sit on the end of the language model, you see all your difficult questions, your difficult math being answered. It doesn't prove that the machine actually understands it, or really, really digest it, or do it the way a human would do. They can do it in a very different way, and that way, by now, happen to be next word prediction, right? So that's why, among scientists, among engineers, we tend to be less amazed by this technology. And we knew it is going to, for example, I'm not surprised at all that in one day, in fact, very soon, that a large language model could get a gold medal in an international math Olympia. Because that type of reasoning, that type of problem solving is doable through a network prediction model, as long as you have a big enough brain to remember zillions of words, prefix the sentence, and then the same amount next to that. Yeah. But I also know that there are some questions that they cannot answer, even through a very, very simple interface. I've tried that. I reserve that question list. If you are interested, I can send it to you. Yeah. But I tested even the latest strawberry. They still cannot answer, right? So, but to a general public, they need education, I think. Right now, the AI literacy is very, very different from how much we know about algebra. Some people are very poor at algebra, but they know what that is. They wouldn't be surprised to see a calculator. But on the other hand, the AI literacy is much worse right now. When people see something amazing, they literally get scared. I think there is a need to enhance the education of AI. It's not about just math and programming. There are other dimensions regarding AI utility, AI measurements and business and products that the people should know. Then they can have a much, hopefully authentic and realistic view about AI, even without knowing the mathematics and programming. You don't need to be a mathematician or a rocket scientist to understand AI.
That's the fascinating thing to me about AI, is that it is possibly one of the most multidisciplinary technologies that I can think of. You have the technical aspects, the computer science and the math, but there's also a lot of philosophy, human psychology, neuroscience, linguistics. The list kind of goes on. In terms of what you're talking about and the core of what language models are and what they do, which is a point that, I appreciate you for bringing up because it's not talked about often enough. And this kind of race to intelligence and what intelligence is and what human intelligence is. And the fascinating thing to me is the kind of stark differences between language and intelligence and how these two are not necessarily related. And in interacting with these chatbots, right, I feel like we as a species communicate our intelligence, our thought through language. This is our medium. This is what sets us apart.
Yes.
And when we see something talking to us, right, in this medium of how we convey our intelligence, it's easy for us to assume that it also possesses that spark, right?
Yeah, that extrapolation is very natural for human to make. Yeah, but even so, I guess it is not difficult for us to realize that even if we don't speak, we still function, and we can still communicate. You have gestures, you have many sensories that can sense, visual, audio, temperature, all sorts of things. And not all of this actually was described in language. In fact, language can not be used to describe everything. There are many reasoning that is existing outside of language, right? So I would really draw a difference between the functionality of communicating and functioning linguistically versus being intelligent, because intelligence is again very, very subjective experience. It's a user experience. It's not a measurable functionality, I would say.
It's so much more. I think the fascinating thing about what we're seeing with generative AI is that...
Now there is one more thing, which is oftentimes we call the soul, the spirit, of a creature. I have to say that I'm very limited in my knowledge in understanding that part. I don't know what that exactly is. Can we assume that just by become knowledgeable enough, I automatically become soulful? I'm not sure. I think there's a difference between a machine and a biological creature, and that difference is actually at least not well understood at this point. I think the older generation philosophers had time to think about it. Kant, Hume, they actually debated, on what is the status of, human reasoning and human morality and the will, in the definition of human versus, machineries. I think that discussion and that debate and thinking should continue or restart because now we have a new technology, which is AI. At that time, they had this discussion because of the latest invention, which is the calculus, the orbiting planets and so forth, which was fascinating. It gives you the feeling that, wow, I'm like a god. I can predict the position of the planets. I can predict the ellipse and so forth. And then people start to think, oh, what is knowledge? What is reasoning, right? What is a conscious, so forth. I think now it's time to rethink about that because with AI, which we actually can make in a mechanically using a very, very simple training kind of strategy, say network prediction, how can we redefine what is ration and what is mind and so forth, right? But I would caution people from making the jump of directly connecting a very, very capable and seemingly smart artificial system to a human-like creature which has the ego and also maybe even the malicious intent to come after us. I think there are a lot of steps, even philosophical ones and cognitive ones, between them. And drawing an automatic extrapolation is not very convincing, at least to a scientist.
The point you brought up about the soul, I find that fascinating, and that's the kind of these differences between knowledge and having been trained on every human work ever written, and the different facets that make up what human intelligence is, and it goes beyond knowing things. The stuff that makes humans human is not that we know things.
I had one interesting debate with a colleague. For example, we train generative AI, such as the Sora, for producing movies. Now, let's imagine that the system watch a lot of animal kingdom movies, like animal fight each other, eat each other, and so forth, so that they can produce similar movies. Along the way, are they going to be learning the will of killing and of predator and prey type of mindset? Well, nobody actually knows, at least at this point. But it's a fascinating question to ask, at least.
Intention is a big thing here that's missing, but there's also a lot that's not known about language models.
The real risk I do see, in a potentially out of control AI system is not about they kill people and so forth. It's about their environmental footprint. Imagine that if you do have an AI system that is told to infinitely iterate, on some very, very difficult objectives that actually can be measured, but they can go very, very big. What if the machine decides to keep training themselves and burn a heck of energy and so forth, and causing really environmental disasters? To me, that's a real risk we have to be careful about. There has to be checkpoints and breaks, so that at least a person should be allowed to turn it off, right? If you want to build a system that is never having a switch, probably no good, right? But these are something you can already bear in your mind when you do the design. And we could call it also a regulation in the science space, but I don't want to overgeneralize that. It's not like everywhere. It's only a very, very definable and measurable risk that is indeed very, very grave. But on the other hand, I think it is manageable.
Right, and a lot of these risks come from putting these systems in a place where they can make decisions without human oversight. And I guess the immediate and obvious remedy is don't do that. Maintain human oversight, you won't have those problems.
Yeah. That's true. So I think it's an ongoing discussion. But again, there is still a difference between the scientific kind of brain work, or maybe even the technological experimental work from the development, the production and deployments and the usage. I would imagine that it's more effective and productive to focus on the latter. Also, one more thing. I think AI, compared to other sciences, has the advantage that it is still one step away from the physical world. Imagine that you are a biologist, you do virology and genetic engineering. Well, the products of your experimentation is a physical being. If you somehow smash the glass or you somehow cause a lab leak, it actually does enter the environment, and they will stay there, or they could spread, just like what we see in COVID, right? So these are very material risk, and therefore it requires rather stringent regulations and control. AI maybe conceptually have that kind of same risk, but it is fortunately still in a digital and a virtual environment. In the worst case, you just throw off your iPhones and shut down your machines. You go back to the caves. We will still survive, right? And without for example, computer. Of course, I know it's very difficult these days, but I mean, it's a different level of risk. That existential risk is different from a biological disaster, a chemical spill, a nuclear kind of explosion, and so forth. That's very different.
A part of the regulation question, and all these topics are so passionately debated in the public space, is the idea of open source versus kind of a lot of what we see from the companies, which is super, super closed source. We're not even going to tell you what we trained on. That has to come out through reports from investigative journalists, right? And it trickles out and is fought over in court because of copyright concerns. But the kind of debate hinges on this idea that science needs to be open. Science needs to be explainable and replicable. And if it's not open, it's not really science. And it's the distinction between product and science, right? But there's also concerns about what open source could mean for security risks. And you were talking about chemical and biological situations and how AI open source can maybe help bad actors in those realms. So as it relates to that and making sure that nothing bad happens, what are your thoughts on open source?
I don't want to reiterate the philosophy in science that there is a fundamental value of share and open and so forth. Definitely I'm for that. More than that, I actually don't think secrecy is a recipe for security. I think there's a fundamental issue. People thought by keeping things secret you become safer. I doubt it. I don't think history gave us too many examples of that, because you eventually you will lose the secrecy. I think having more people to understand the technology, to be able to investigate and experiment, creates a much larger pool of people and also a large pool of knowledge to contain the risk if that risk happens. That's kind of, again, maybe a more philosophical and abstract argument. But I can give you a few examples, right? So right now, we don't actually know exactly, how GPTs are trained, okay? Do you think that makes the technology safer or less safe? Well, I don't know. I feel less comfortable if I'm using something that I have no knowledge from. Yes, I'm not going to, break my car and do it myself, or understand, how it is made. But at least I know that there are more than one manufacturer who knows how to do it. If my car breaks down, like I have to drive a Mercedes, I don't have to go back to Mercedes. I can go to any car shop to have it fixed. That makes me feel safe. So under the same principle, I think important technologies, I'm not even arguing a commercial reason. I think many of the arguments was because of a commercial interest and other geopolitical interest. But from a security standpoint, open source has the advantage of sharing the knowledge, to more people, and also keeping the technology transparent for scrutiny, and therefore, for a better opportunity to regulate it. So I think that part is very important, even from a pure security standpoint. Now, of course, there are even more argument about the economical and the scientific kind of value from it. Economy is obvious. You don't want a lucrative and important technology to be monopolized by one or few companies. That's why, in the US, you have the antitrust laws and the anti-monopoly laws, right? So if your company, Rockefeller, once they own all the, petroleum production, the government orders it to break it. There is always an interest of a healthy competition, among entities, for key technology and key product to actually better, the quality of technology itself, and also to make it affordable and accessible to people. Right? So that's a commercial argument I want to make. Open source give startups, give even universities, a share, of their impact and also their ability, to innovate, in this market. Then scientifically, even more important, I think no science actually gets developed very well, if it's kept in secret, right? So for the sake of advancing the science of artificial intelligence, especially in United States, definitely, US is right now the current leader. I think, by having, the open source community, very robustly grounded, in the United States, actually end up helping United States to being the leader for the past many decades, in IT technology. Look at, for example, the development of operating systems like the Linux, the search engines, and many of the novel IT innovation is because there is this openness of technology to be played and experimented and advanced, not just by a designated player, but by the entire academic and industrial community at large. Right? I think that capability and freedom is nowhere to see. In fact, elsewhere in the world, and not even in Europe. In fact, that's part of the reason I become excited to take on this job in here, because I do like to see such a mindset and such a value, a principle in education, in technology, to impact, regions which are yet to be impacted. So here is, a young country that wants to have a voice and have a stake in the global technological advancements. And they have the resource and also the ambition and also the enthusiasm of being a leader. And absolutely, I think, by, moving or maybe I'm lacking the right word, by learning or maybe by advocating and advancing, amplifying in that kind of openness, that kind of transparency, from the very beginning of the foundation of this university and of the talent we are training, I believe is at the end of the day helping, to grow this technology. And that's also why in our university, we indeed take a very, very open, but of course, compliant and regulated approach, to develop our AI. You may have heard about, of course, everybody heard about Llama, from Meta, right? And it's a huge, benefit and support to the community, and it benefit a lot. A lot of researchers working on that and maybe inspired a lot of new advancements. In here, we have a project called the LLM 360, which actually went even multiple steps further. We not only open sourced the model weights, we open sourced the checkpoints and also the code that you use to produce the model. And our goal is to let researchers to be able to reproduce the result, good and bad. And because otherwise you can only use it and augment it, but you still have this dependency of waiting for the next version, for you to rebuild everything from scratch. And in our case, we want to make the community even bigger, with this higher degree of transparency, right? And I think, does that give us any risk? Well, you can never rule out the possibility of a bad player somewhere in the world to take that and turn it into somewhat a malicious tool. I don't think that's going to be stopped if we just close source it. People will figure out from else places. But on the other hand, by opening the technology in such a way, we end up having more people understanding how to augment and how to manage and contain the risk from this machine and how to make the machine better. So again, it's a debatable topic, but I just want to share with you my view from a developer and a researcher who makes these kind of technologies. I think the benefit will outweigh the risk.
Right. And we talked about this a little bit, but the thing that I think is important, right, in the realm of AI literacy and helping ordinary people who don't spend their time reading research papers or writing research papers about AI, what are the biggest misconceptions that you see people make about artificial intelligence in general that maybe you want to clear up?
Well, all the things that we just discussed, like taking AI as some sort of a creature, that could spin out of control from human hands, is definitely one perception, and also exaggerating, the power of AI, in real human life and also in scientific exploration. In my opinion, is also a misconception because, AI is very powerful, but it is powerful in certain dimensions. For example, it is very powerful now in playing the game of chess and Go. But it doesn't mean that it plays other things well, like planning your trips, right? So it takes time to get there. Another misperception is that AI is only about large language models and the GPTs. In fact, AI is a very, very broad technology that is more than actually we expected, to be coexisting with us already. Our search engine is also an AI tool, and I don't think people want to ban search engine, right? And also, now everybody is driving a car with a GPS or with your iPhone next to you to show you the road. I can tell you that I'm old enough that I live in the age where I use a paper map to drive. It's painful. I don't want to go back to that age. People don't realize that that function is also from AI. So AI is already everywhere, right? So using the GPT as the main or the only representation of AI is itself a misperception, and therefore the discussion around AI sometimes is very, very confused and ambiguous. Maybe we should say that how about we discuss large language models? That's actually a lot more precise and better scoped. But when you say AI, literally you are talking about how about we take a Google map from your iPhone. That's a part of AI, right? And who knows what will come along that line, the next product. I think self-driving is one of the major things, that is coming very close to well, it's already realized. It's just like right now the policy is lagging behind, for its deployment. In fact, I think a policy is more needed over there in terms of deployment, because if you look at the statistics, the accidents committed by a autonomous driving car actually is lower than people. Okay, and the reason why it is not widely adopted is a policy and infrastructure issue, not necessarily a technological issue, right? And so I think there are a lot of examples in such a space where especially decision makers and policymakers will be benefiting from having scientists and developers next to them to be part of the discussion. I have to say that I've been to events in various organizations and the government bodies where a scientist like myself could amount to 5% of the participants, or even less, right? So in that environment, it is amplifying, in fact, the misperception, not actually reducing that.
We talk about people kind of trying to educate themselves better, and like you were saying, it's really difficult. A lot of this is ambiguous. A lot of the language changes depending on who you talk to. What should people be doing about AI right now? How should they be kind of going about thinking about it? I think there's a degree that some people are afraid that it's too complex, too out of reach to have an opinion on it, or to think about it too much. What would you tell them they should be doing right now?
Good question. I have to say that it is not, I don't want to push the blame to the public just because they don't do enough. I think the general public, even including decision makers, policymakers, I genuinely believe that they wanted to know more, but they don't know where to learn and how to learn. So our educational system should be the starting point, that our current curriculum, regarding AI or computer science, probably it's time to revisit them. In fact, for the past, I would say several decades, if you look at the curriculum, there hasn't been a fundamental change. It's literally just about how much I teach along the same line. Which programming language? Okay, I can start it from Fortran in the 50s, and then C, and then Java, and now Python, and so forth. But it's still about teaching a different language. Mathematics, well, there are new material coming in. Let's retire the older ones and bring in new one. But you need to know linear algebra. You need to know calculus, and so forth, right? So it's still the very, very conventional way of thinking. And the statistics, for example, are still using a year to teach regressions and so forth. With now AI and with functions like GPT or search engine and so forth, in fact, we already are in the crisis where some people are using GPTs to write scientific reviews of the submitted publications. And people are getting very frustrated, but you cannot stop it. It's happening, right? So then your attitude toward even published papers may need to be augmented. Are they really the product of the researchers, or it's a mix, and so forth? So I think this awareness of the changing technology should be first taught to the public, in some curriculum. And that material does not require you to know calculus and know linear algebra and know all this fancy mathematical stuff, right? And in fact, it could be taught even in elementary school and high school, right? So I think bringing the AI into the background, of all teaching materials, make them not a specialty, but a very, very horizontal, fundamental science, is probably where we want to begin from. Start early and start very, very simple but broad to create an awareness about what we already are using AI to do, and how well they can do, and what else we set forth for them to do. That kind of high-level knowledge can be already kind of taught to the general public without any emphasis on technical specialty. Then you can talk about the connections of AI with all disciplines, not just AI for science or AI making a product. No, we talk about even, for example, artists are already using generative AI to create, visual arts and music and many other things. How we appreciate and interpret these kind of outcomes, and how can we redefine copyrights and maybe authorship and all that kind of things, right? I think these kind of issues are already happening, but very few people really put time to think about it, or not even maybe knowing it. So I think the AI literacy is really about awareness of such a entity, such a capability. We all know, for example, the capability of linear algebra, or not linear algebra, just algebra. That's why we are not afraid of a calculator, because we actually know algebra, even though we don't know how to do algebra, but we know what is algebra. Right now, we don't have such a literacy, in AI. And that's where, from the educational standpoint, I would like to see universities and even going further earlier, high schools, elementary schools, start thinking about that. My son is in high school right now, and I sometimes look into his curriculum, right, and try to understand how much their teachers and principals actually know about all this. I think it's fun to keep an eye on it. Then, given that's happening, I have more to say to the general public. Hey, go read such material. Go watch a few informative videos on YouTube and other places. But on the other hand, go ignore certain kind of information that you get from all different sources. There is definitely a difference of good and bad information, and there is also a judgment that you have to grow to be able to tell what is really maybe valuable and authoritative, authentic, versus what may be something suspicious. I think again, I'm not a fan of just clean up the things to make it like a hospital and a clean room. In fact, if you look at evolution, both in terms of a biological entity or even evolution of our brain, you evolve and you become healthier because you have adversaries. You have all these viruses, you have all these pathogens, you have actually all these misinformations, from your world, and you co-evolve with it. You end up like developing your own immune to be stronger, and keep you away from all this isn't going to make you healthier. In fact, it makes you weaker. I don't think the politicians and the general public appreciate that. They want to be as safe as possible, away from all risk and all kind of pathogens, psychological pathogens, or biological pathogens. I think it's going to weaken our civilization. And then when you have an adversary, we talk about China, we talk about some other countries, what if they don't do that? You will eventually run into an adversary that is healthier than you, and that would be even worse, right? So I would really advocate, a culture of openness and also bravery, to embrace, this reality, and then try to take on it.
Thanks so much, Eric. This was an absolute pleasure.
Thank you very much.